So what I want to do is spend a little time, and as we were visiting customers, what they said is, IMS APIs, yep, we're already doing that. And as we talked to them and we asked them, well, how are you doing that? Are you having any issues? What problems are you having? We found out that in some cases, there was a lot of war stories out there. There was a lot of lessons learned. There were successes and there was failures. But as anything, you try, you fail, you try again, and you succeed. So one of the things I wanted to do was put together some of the stories, some of the things you need to be aware of. So the first thing, as I went through customers, they told me, hey, you know, we're doing integration, we're doing modernization, we're creating APIs, and we have an ESB to do all that. And that was kind of their standard answer is, yep, we've got an ESB. And when we pressed them, we said, you know, this is what I would call an ESB. It's an enterprise service bus, and this, actually I stole this from someone else, and this is the old, kind of the old picture of what an enterprise service bus. It's kind of a common environment. Clients, interested parties, systems, they register on the bus and they either push or pull things off of the bus. And as you can see, there's a lot of things that are on this bus. You know, there's applications, there are integration systems, and then kind of at the bottom right, there's something called legacy systems. And they kind of group that as, hey, here's where we're going to do the mainframe. But if you look at this, kind of what we said is, well, you know, there's more there. You know, there's RESTful services, there's SOAP services. There are things on your mainframe system that don't fit well into kind of the API world, if you wish. Things like applications, things like 3270 applications, other transactions, and the mainframe kind of broke that a little bit. In other words, what we found out is there were a lot of customers who said, I have an ESB, it does all this, when in fact what they meant is they had some software packages embedded in the system, they had an ESB. It didn't do everything, but that was kind of their common answer. So we kind of drew this picture and said, this is kind of what you're talking about here, right? And then the next question they said is, well, what else don't I know about, or what am I confused about? And the question we said is, well, do you have the right mainframe integration technologies? And when you ask that global question like that, they said, well, what do you mean by that? Well, and you know, how old are your legacy back-end applications? My definition for legacy code is the code you put in production yesterday. But in some shops, they equate legacy with mainframe systems. And when you say how old are your legacy back-end applications, I had an example of a customer that we were working with them to expose an IMS transaction as an API to a distributed system that was being driven by a UI, our user interface, or a tablet. And when we looked at their systems, this particular program had changes that were made to it in 1979, 40 years ago. And it was still running production. It was still running fine. When it was written, none of the new technology existed. And in some cases, some of the decisions that the logic was following in the program was based on systems that were 40 years ago. It was responding to a terminal. It was responding to something else. So when you start looking at systems, you kind of need to look at, okay, what was the application initially defined to do? It doesn't mean we can't expose it. And then what technologies are they using? Well, we started looking at systems, and they said, well, you know, we have these systems that were pushed out by some of our applications back when, and they have some embedded technologies that we had to look at. And then, is the application code structured or unstructured? And you may say, why does that matter? Well, if the code is structured, it may have been designed where there's a lot of programs that call a lot of other programs that call a lot of other subroutines. Things like message switching. You may have one transaction that does a function and it switches to another and which switches to another one. When you start exposing those as APIs, you may run into some issues. Like, for instance, transaction 1 calls transaction 2, which message switches to transaction 3. And you may want to expose transaction 3 as an API, but you find you can't because it's expecting to be passed, like in a conversation, some data had to have been done by transaction 1 or transaction 2 before transaction 3 can even run. So you may find out that you have to kind of mimic that being called or call the whole conversation. Also, did your core applications that you're trying to expose first start out as commercial offerings? We run across customers, and what they have is they are trying to expose systems that were initially maybe created by a vendor. That vendor has ceased to exist. They've taken over the code. They're now supporting it. They've added changes to it. And maybe the people who wrote it, again, aren't in business, or maybe the people who added the changes aren't around at the company anymore. So there may have been commercial offerings that were out there that are now in-house, but they started out as commercial, and you need to be aware that they may have coded things in different manners. What third-party components are embedded in the code? This is another we run into. You may have a piece of code, and it could be a commercial offering, or it could have been house developed, that in the middle of the code it calls a subroutine. And nobody really knew that subroutine was there, and maybe it was prefaced by filling in some data in a field or calling another program, and you run into the fact that all of a sudden your API doesn't work. And you realize that it didn't work because you didn't pass the value into the calling program that it needed to call part of the embedded code in the system. Then we get into complexity. How complex is the code and the data structures? We have run into this at several companies, and what I'll call it is the programmer shortcut, is they define a copybook, an 01 level copybook as defined as 20,000 bytes. Then right after that, there's another field that redefines that for 10,000 bytes, and under that, there's another copybook that redefines that for 5,000, and so forth, and you find out that you've got multiple levels of redefinition, multiple names, and multiple fields that you have to use, and it could be even different data types. You could have a field defined as a character that's redefined as a numeric, that's redefined as something else, and depending on how you reference that field, you may have to do something different in the API. Also, you may have code that references parts of this, so you kind of need to look at that also. Again, things you don't know. One of the big things is, does your staff actually understand what the application does? We have worked with customers, and they would say, okay, we want to expose this program or series of programs as an API, and it does this. And then when you get in there, you find out, well, it didn't really do that. You know, program 1 only calls program 2 on certain situations, and you have to cause that to happen. So sometimes you need a discovery tool or some sort of discovery mechanism to actually map out the interrelationships of data and transactions. How many coding standards have been used over the past years? An example of this is we're working with a customer where they have had at least 4 different groups modify the code. First group wrote it. The second group actually used a case tool to generate other pieces of the code, and the third person or group actually wrote it a different way. So you have behavior where maybe the input to your program looks great, but then when you get an output, maybe group 1 coded that in IMS terms. If you think of a screen or a message coming back, you get a header at the top, you get a body message, and you get trailer. Okay, you get 3 messages coming back, you deal with that. Then you find out the next transaction actually has, instead of the header, it has 3 header messages, 20 body sessions, 20 body messages, and 3 trailer messages. And you have to figure out that behavior is not standard because the groups that wrote that were not standard, and there were different groups over the years. Then I'll explain the chocolate to the right in a second. But most mainframe applications were designed to interact with 3270 terminals. End-user dialogues, things like you came to a master page, you selected an option, you drilled down into a function. So you have to think about functionalizing what that application is doing. So in other words, you may have, okay, option 1 causes an account lookup, which asks for information. That's a function. You have to start thinking, okay, the original application was designed to be driven by a human, and you want to functionalize that into a functional or an intelligent API that goes after the real data that you need. And again, what we want to do is make it transparent to the back-end system. So in other words, as I mentioned, programs that were written 30 and 40 years ago to interact with a terminal or interact with another program shouldn't have to know that now they're being invoked by an API or a UI running on a mobile device or a UI running on a tablet. They shouldn't have to be told that's what's happening. And again, that leads to my next point. Changing legacy code to work better as an API introduces more complexity and more code. If you have to write code to drive code, then you're actually introducing another level of code to support. So it works better if you can actually expose your existing IMS transactions as an API without having to change the source code, without having to change the behavior of the transactions, and without creating new code that you have to support. And, you know, we hear a lot today in the news about microservices or fine-grained APIs or atomic APIs, and there's many ways to build those, and they may be easier to build, but they may put more work on the consumer of those APIs. And I'll show you a chart in just a second of what I'm talking about. The more intelligent the API, the less effort for the API processing logic. That kind of makes sense. If you think about a banking example, if I come up with a banking example in finance where I have a savings transaction, a checking transaction, and a mortgage transaction, if I have to execute all three of those, then the API has to orchestrate calling those. It would be better to have kind of an intelligent API that says, get customer account, and underneath it, it does all the orchestration of those services. Now to the chocolates. So this is from a quote from one of our salespeople. Legacy mainframe apps are like a box of chocolates. It is hard to see what's inside. I mean, if you think about that, which happens to be a partial quote from Forrest Gump, the movie, where it says life is like a box of chocolate, is if you look at those chocolates, they all look like they're candy, but you really don't know what filling is inside of those. And it's kind of like that with the mainframe applications. If you look at it and say, yep, that's an IMS application, but you really don't know what the behavior is going to be till you get inside of it. So if you think about that, what we did is I took a picture of an application. In this case, it just happens to be a Kicks transaction. This is very simple. You see 6 or 7 lines that says, okay, it accesses this, it talks to this database, it's mapped by these screens, it executes these load modules, it branches to other load modules. You very quickly realize that this is simple. This could be like 50 lines coming out of it. So the first thing, when you talk about legacy application complexities, and I'm going to talk mainly IMS now, message switching. You have an issue where you start a transaction, it then message switches to another one, which message switches to another one. And I was at Share last week, and someone from IBM Level 2 was there, and they said that they had talked to a customer, and the most message switches that they had seen in a company was 23. If you think about that, one transaction that spawned 22 other transactions. Now in IMS, based on your commit mode and your sync level processing, if you pass a transaction through IMS Connect, it opens a T-pipe. Then that transaction message switches to 2, which switches to 3, which switches to 4, which switches to 5, and 5 responds to the client gets this response, and it's happy. The problem is if you don't have the right level settings in IMS Connect, that T-pipe is going to hang around, and you're going to have a lot of them dangling around. So you have to consider that behavior. You know, the application will be happy, but IMS Connect will not be happy with all those T-pipes hanging around. Also, multiple program calls. You may have one program that calls another program, and you really didn't know that was happening until you actually look at the behavior of the API. Also, in our history of IMS, there are different ways to pass messages. You can have a multi-segment input message, and you can also have a multi-segment output message, which means that in the old days of applications, when you were using the 3270 screen, you got your first screen back, and you would PA1, or you would use logical paging and page through the format coming back. Well, if you think about it, you can't do that sitting out on a mobile device or a phone. You want the data passed in a consumable way. So in other words, you have to be able to handle the idea of multi-segment output and package it in a way that the application can intelligently deal with it and pass it. IMS is perfectly okay just to throw the whole buffer at you and say, here's your response, deal with it. And so that is one thing you have to start thinking about, is how to deal with that. Also, you may find, based on the way the applications were coded, not only do you have multi-part messages and multi-segments, but you have variable length segments. So in other words, it's not just, hey, you've got 10 records coming back, 10 segments coming back. You've got 10 segments coming back. They're all different length. And oh, by the way, they're all mapped with different copybooks. So you have to deal with those complexities. And again, you don't really know that until you get into the way that the application is going to behave. Then you get into, as I was mentioning earlier, the complex structures, the redefines or the occurs depending ons, where you have data that exists in one state and can be redefined and exist in another state. The example I used is you have one that's created as character, and then it's referenced again as numeric. That's going to get you an OC7 if you pass the wrong data into the wrong field into the transaction. And again, if you don't know that and you don't know the data, you're going to run into issues. Now, this is one of the things, null terminations and non-standard code. We found this at a customer that over the years, as updates are being made to the data, they would put hex zeros in the middle of a field. Well, COBOL is perfectly okay with a hex 0. MFS is perfectly okay with a hex 0. But if a modern language like Node.js or Java or any of the new languages see a string with hex zeros, it terminates the string there. So if you've got a 50-byte field and you have 10 good bytes, hex 0, and 30 other good bytes, it's only going to let you see the first 10 because it's going to interpret the hex zeros as null termination, end of string. Also non-standard code, things like we used in the past to compress data, the hex 3F character that is put at the end of some fields that we used to use to allow, fields like that were 20 bytes long and they had a name like mine, which is Rivers, which is less than 20, you would see RIVERS, hex 3F. MFS knew how to pad that. That character, when passed back to an ASCII client, may not translate and it may come back as garbage they don't understand. Also screen macros. If you think about, we've run into this where the program runs and it doesn't get the correct data. And what we find out is when the applications designer first created this application, there were fields on the screen that were defined as numeric, but they were zero filled. Now the program has no idea that's coming in. But the behavior of the program was driven based on situations that the screen designers knew, okay, I really am not going to plug in these fields, or I'm going to cheat and I'm going to plug in a 0, or I'm going to plug in a value, or I'm going to do numeric checking. And what happens is you expose that program as an API and it doesn't work and you're like, why? And you start looking at the code and it's saying, oh, it's an invalid number, and you didn't realize that in the screen macro and in the MFS definition, it zero filled it. So you have to start thinking about those kind of things. Another one is conversational programs. In IMS, a transaction starts up, it starts a conversation. The conversation ID goes into the pool. There's a scratchpad area or a SPA that's created. Transaction 1 runs. It calls transaction 2, transaction 3, transaction 4, and the SPA gets passed. All of that is fine, except when you try to expose maybe transaction 2 as an API and realize that it's actually part of a conversation. So you need to expose the entire conversation as an API. So the whole start transaction, next tran, next tran, next tran in, and terminate the transaction so that the conversation ID and the conversational thread is deleted from the pool. The idea is you can expose that, but you have to have some degree of control and flow capability to expose the whole conversation. And then if you're talking to external systems, maybe your mainframe to call out to another application or another platform that's a RESTful API, or that is a SOAP API, or a .NET API. You have to be able to talk to external systems. And then there's some 3270 applications. We work with customers that they're talking to a third-party application that is not in their company, and the only way they can talk to that system is via a 3270 interface, but they don't want to do screen scraping. Is maybe what they want to do is they want to represent that 3270 system via an API and call it as an API via a RESTful API or SOAP API. And again, you run into that complexity when you try to do that. And again, I mentioned conversational transactions, but we're into an issue where your conversation starts with tran 1, it runs tran 2, tran 3, tran 4, and you think that's great. You stop the service, but then what you realize is underneath, it really needed to call transaction 5 to actually issue the commit that actually commits the conversation. And what happened is you ended the conversation too early in your API, and it rolled all the changes back. So you thought it worked, but it didn't because it rolled everything back. So if you think about APIs as building blocks, and again, I stole this. In the U.S., we have Legos. All these little guys are trying to build applications out of these Legos. And if you think about them, some of them are short. So if you think of a Lego has little plugs in the top, and they all fit into each other. It doesn't matter whether it's a 2-plug Lego or a 4-plug Lego or a 6-plug Lego. The idea is you can plug them all in because they can all talk to each other because they all have standard APIs. So in some cases, you plug APIs on top of APIs, and in some cases you're constructing APIs based off of APIs that have been created in the past, but you want to reuse those in an API architecture. And then you have this. We're in the mode these days, and I was talking to Trevor about this before we jumped on this call, is now we're not only creating APIs that are just mainframe. In other words, we have customers. They have IMS APIs, COBOL APIs, RESTful APIs, SOAP APIs, vendor APIs, .NET APIs. So they're constructing APIs from multiple platforms to create a common API experience. You have to have a standard interface to make this work. Again, using the analogy of Legos, since they're all pluggable, you have the ability to do that easily. So this is the chart I kind of wanted to get to. Is if you think about this, if you look at the left, the lines of businesses are driving that we do things today. The list on the left will continue to grow. There's web applications, there's common off-the-shelf products, ESBs, clouds, intelligence tools, and now we have new tools like blockchain or AI doing cognitive assertions or robotic process automation. The idea is somewhere out there there's an API processing logic, probably discovering these APIs through a manager, and they're requesting APIs, microservices, things like get checking, get savings, get car loan, and you have a simple REST API provider. It provides a REST API that has an input and an output message, usually mapped in JSON, and it's going to map input message, output message to the provider. And again, that provider all the way to the right can be IMS or any of those other tools. And you start thinking, okay, I'm doing this today, I'm doing great. And then you start saying, well, what about all this other stuff? What if you want to manipulate data in the API? What if you want to do if then else to control a conversation? Or what if you have an input message and 2 output messages? How do you differentiate what output message is coming back? Then as I mentioned earlier, things like message switching, multiple input and output messages, variable length records, complex structures. How do you handle the null terminations of the non-standard code? Or how do you handle multiple transactions that you may have to run them in a particular sequence? We have a customer that to run transaction 3, you have to run transaction 1 first, and it makes an update to the database. Transaction 2 expects that update to be there, and transaction 3 expects 2 to finish. You have to run those in a particular order for the APIs to even work. Again, what about the screen applications or third party? Or what if you have those other things like IDMS or Natural or other systems in your repertoire that you need to expose, and conversational? What this means is the simple model changes to more complex. What you're going to do then, if you look at the arrow, the consumer API way outside has to start handling these differentiations, how you're going to control these behaviors. So kind of what we have said is, obviously we have a tool that does that, is you want to create an intelligent API, an API that allows you to orchestrate not only the simple APIs that are created by other tools, but all of this other stuff, the manipulation, the flow control, the multiple transactions. And you don't want to have to write code to do that, as I mentioned before. And if you see to all the way to the left, then you're going to start seeing intelligent APIs that are more like get customer, that it may run 3 transactions under the covers. That get customer can then publish into the API manager, and the consumer is then going to discover and run that API, not each individual microservices. Also, maybe if you look at the bottom, you're going to be calling out to distributed apps like the DVM type solution or cloud services or other APIs. And you may want to run this solution different places. So in other words, you may want to run this type of intelligent API process on the mainframe, on the IFL running Linux on Z, on a Linux server, on a Windows Java server, or you may even want to run a hybrid solution. The idea is you need to take into consideration all of these complex situations. So we were in a meeting a couple of weeks ago in a couple of places, and if you would have had this meeting with the IMS group maybe 5 years ago, they would have said, right, I've got my IMS DBAs in here, and we're talking about moving something to production, and so I've got my IMS guys here. everybody is happy. Well, a couple of weeks ago, we had these people. So to have a completely integrated application, we had the IMS group, we had our group that was doing Ivory, we had the GitHub people, we had Jenkins, .NET, Java, Node.js, COBOL, they're running JBoss, Tomcat, they're using MoogSoft for a distributed dashboard, they're using Dynatrace for distributed tracing, and they're using Urban Code for a complete distribution tool or DevOps solution. So if you look at all of these people, what used to be just the IMS people, you have to use a lot of other people. So again, you don't know what you don't know. You have all of these other groups that are now involved in creating APIs. So one of the things as we work with customers is, how do you design these? Well, do you want to come up with a design methodology where you say, I'm going to expose each individual transaction as an API, and then I want to create something called a composite where I have a composite service that calls those base services where they can be reused, and then you start thinking about, well, we're getting more and more calls these days for outbound calls to third-party software from COBOL. So you have to start thinking about the design methodology. So something like this. This is actually a representation. I know you probably can't see this. It's very, very fine grain. This is one IMS transaction that has 10 possible outcomes, 10 possible outputs, 10 possible message formats. In some cases, multiple segments of messages formats. This is an intelligent API where we control that control and flow. Then in the financial, what we're looking at is not only is IMS, and I would say pretty much to a person, everyone we talked about, IMS is their system of record. IMS is their backbone. IMS is where all of the systems of record are held. But they've got other information. In Europe right now, there's something called instant payment. This is being driven by the government. This is not being driven by the banking industry. This is not being driven by standards or companies. The governments have said, we want to reflect the payment immediately. So what that means is the mainframe systems who used to process the payments must immediately call out to a transfer agent or a payment service to reflect that payment instantaneously. There's no longer a 1 or a 2-day delay to update that data. We have customers doing outbound calls to Google resources. You look on the right, there's a geocode that's provided for mapping and Google APIs. We have customers on the mainframe that are calling geocode services, and that's a RESTful API. They're calling out to credit resources, account control. We have one customer that calls out to a worldwide terrorist checking system that when they create an account, they're mandated, they have to verify that, in my case, Dusty Rivers is not a known terrorist and he's opening accounts, is they verify that real time from their UIs, from their 3270 systems. It's doing a real-time call from an IMS program outbound. They're also doing inbound API changes to existing IMS transactions, and in some cases they're using ATMs using APIs, both SOAP and REST. And I use that example on the right, is if you look at all those payment services, that pops up on every single website you go to is PayPal or Visa or MasterCard or Amex. You're having to discover those services, and most of those payments are being driven by mainframe resources. And kind of what have customers asked for? So I'm just going to go through these real quick. JSON Web Tokens. As you get into RESTful APIs, you have a different security paradigm. So I'm not going to go through this, but this is just the flow. Encoded, it looks like gobbledygook. Decoded, it's a little bit easier to read, and each JWT payload has header, payload, and signatures. So if you wanted to process that, if you want to massage that, you may need to do something where you actually input the JWT, you can change some of the tokens, you can change some of the assertions, and then pass it on to another service. Also, callable services. And again, I'm not going to go through this a lot, but it's basically the ability for a mainframe system to access SOAP and JSON services via COBOL or PL1 and not have to know XML, not have to know REST, not have to know the XML structures or the distributed systems. They just they're thinking they're talking to a COBOL subroutine, and we have customers that are doing this today in high volume environments. Also, in the whole series of DevOps, command line interfaces. You may have an existing interface that you want to create an API, and you don't want to go through the GUI or a GUI form. You just want to say, I've got an open API / Swagger document. I've got a WSDL. I just want to make it callable and expose a program. So there is command line capabilities. And again, this is just some more on the command line. And you also need the ability to do the mapping. In other words, the distributed calls, the mainframe programs don't really have to be concerned about whether it's REST, JSON format, SOAP XML. They're doing PL1 to PL1 or COBOL to COBOL. So you want to hide that level of complexity from them. And again, something like this where you create a control and flow where you access the JSON SOAP and return the information in COBOL format, and you control the RESTful service processing. Now, when we get into security, one of the things I was going to say is, maybe I got one more, is on the mainframe there's a very nice product. And I would say if you're not using it, you need to look at using it. And we actually wrote a white paper on how to implement ATTLS on the mainframe. ATTLS is transport level security sitting on top of your TCP/IP stack that provides security above and beyond, SSL or SSL3 security. So what we want to do is we want to be able to deal with all of these security types. If you think about ATTLS as enforcing that level of security, but you're going to have other security models on the mainframe. There are security products, RACF, ACF2, top secret. If you're in the old world of SOAP, or the existing world of SOAP, you use WS star or SOAP headers. Also ATTLS and HTTPS go hand in hand. And now with the JWT and pass tickets, you have to be aware of all these security paradigms as you create APIs. Then once you create the APIs, where are you going to put them? I mean, if you think about if you do a Google for API repositories, you're going to see API Connect or MuleSoft or APIM from CA or 3Scale by Red Hat or Apogee. There are going to be repositories that are going to provide API management, API governance, API control, and all of them adhere to the standard, and you have to be able to deal with all of them. Now, normally I would do a demo, but I'm not going to do that now because I was in the interest of time. So what's next? If you think about the analogy of following the yellow brick road, what is next? So one of the things that we're hearing about, and we actually heard a lot about last week at the SHARE conference, was Zoe. Zoe is the open source framework that is being put on the mainframe. It's being supported by 3 major vendors, Rocket, Broadcom, and IBM. And if you look at this chart to the left, we've been talking so far during this call about business APIs. Business APIs being able to provide APIs for business, applications, and data. But if you think about the normal day-to-day things you do as far as development on the mainframe, you have tools, and they've been around forever, things like TSO or ISPF or REX or JCL or Unix System Services. What Zoe is going to allow to do is using this, where now you're going to start hearing about infrastructure APIs or system APIs. Zoe is providing an open framework for doing things like submitting jobs, creating data sets, stopping and starting IMS resources. And you're going to see APIs from that side that you normally didn't think about having to deal with. And so what we're kind of saying is really, if you want to use this kind of scenario, if you want to be able to control both sides, is you can provide a common tool that will, allow you to do that. Now, there are numerous presentations and documentations on Zoe. I'm not going to go into those, but the idea is you're going to see tool vendors and vendors on the mainframe, and IBM is one of them. They demonstrated how you could put together scripts that you could actually, stop and start IMS regions or, kick off compiles. You're going to see APIs, and in some cases, one API is not enough. You're going to need the ability to orchestrate those APIs into a usable complex API. Another thing is DB2. DB2, with the current release, has provided the ability to expose RESTful APIs out of DB2. And we've had clients say, well, I really need to call 3 different REST APIs in DB2 to aggregate an answer and pass those out. So this is just an example of, I call 3 different DB2 RESTful APIs, aggregate the answer, and call it back. Again, these are things you're not going to know until you get into it. then whatever comes next. I mean, if you think about it, I've thrown a lot of acronyms, and the mainframe pretty much participates in all this. So your IMS systems today, as new things come up, I mean, you know, things like blockchain and Zoe and AI doing Watson or cognitive, you know, this bubble that I have, the blue bubble in front of it, is obviously not all inclusive, and it will, you know, it's not to be the end all be all. But wherever you're going to need API support, and IMS will be there. Now, one of the things, I've got a section in here, and I'm not really going to go through it extensively, but it was from an old presentation that I was asked to modernize. It was APIs, the good, the bad, and the ugly. It was COBOL and PL1 things that started out really good, got bad, and got really ugly. And so if you start out on the good side, you can see where things started out good, but things got bad and got ugly. It didn't mean that they were wrong, it's just that they were used in different ways. Or things like IMS transactions, things that we can do that maybe, you know, like for instance, existing transactions can be exposed as a RESTful API. Well, the transaction may be too fine-grained. Or multiple transactions may have to be used in a service. Or if you go to transactions combined. Things that I highlighted, I'm not going to go through all of these, but I just wanted to go through this one thing. Here's what I was talking about, null termination. If you think about a field called last name, where it's my name and then out the hex to the right, this is what passed over. This is what it gets translated to in an ASCII conversion table. The hex 3F gets translated to a 3-pound A2. Nobody can read that. The same thing with the hex zeros in the middle, where all of a sudden that gets terminated.